Right, question 9. Obviously, first question here wants to calculate mass from weight. We know that weight is mass times gravity. Therefore, we know that mass is weight divided by gravity. Shoving in our known value for the weight, dividing by G, 9.81, gives us 3466, which we're going to put to 2 sig figs at 3500 kilograms. Then he wants us to calculate the moment the ship's weight about point P. Of course, we've got a weight, we've got a force. Force times our distance is the moment. Moment is force times distance. So that is 3.4 times 10 to the 4, the value they gave us up here, times by the distance 5, and that comes out to 1.7 times 10 to the 5 Newton meters. Up next, we need to calculate the minimum vertical force required to start to raise the front of the ship. So we know that if it's in equilibrium, the clockwise moment is equal to the anti-clockwise, and it will, even the tiniest amount of moment greater than that anti-clockwise, that will start to lift it. So we're really just calculating the point at which it's in equilibrium, knowing that anything more than that will cause movement. So we know, going back to here, this is of course a clockwise moment, and so this tension force up must be the anti-clockwise. We know the magnitude of the clockwise to be, like we said down here, 1.7 times 10 to the 5, so we're going to use that straight away over here. So we're going to say 1.7 times 10 to the 5 is equals to the tension force times by 12 meters. And then that gives us a value of 1.416, or basically 1.4, times 10 to the 4. Now, calculate the minimum force that must be exerted to start to raise the front of the ship. Now here, we've established just now what this value of T here is, but it's not perpendicular to the pivot. So we need to find out what this perpendicular component here is. And this perpendicular component, we know the magnitude of T, we just calculated it. We know this angle here is 24. So you can say T cos 24 is the force, and this is the distance. And then say T cos 24 times by 2.5 will be equal to 8 times by F. Once we can set that up, solving is easy. We know clockwise is anti-clockwise, equal to anti-clockwise, sorry. So force times by 8, the unknown force, equals T cos 24, that section there, times by 2.5. When you solve for that lot, it comes out to 4044, or 4.0 times 10 to the 3 newtons.